Hello, everyone. Good evening to all who are in Assam, and warm welcome to our today's session on 15-minute Hikha. And today we are delighted to welcome Dr. Lipika Deka, who is a proud daughter of Assam, and currently she is serving as full professor of mathematics in California, Monterey Bay University here in the United States. And Dr. Deka, she completed her early education in Assam, and where she went to school in Maligaon Higher Secondary School, and from there she uh, completed her higher, school high school living certificate, where she got fifth position, I guess, right, Dr. Deka, from in Assam State Board, and then she went to Cotton College, and there also she passed with much distinction, where she got eighth position in Assam, that is eighth rank in the higher secondary, and then she pursued her higher education in St. Stephen's, which is one of the premier colleges in Delhi. And after that, she got the prestigious Commonwealth Scholarship, where she went to study mathematics. I think it was master's in Cambridge University. And later, uh, she completed her PhD in mathematics from University of California, Davis, here in the United States. And now she is, as I mentioned, she serves as professor at University of California, Monterey Bay in the United States. And also she is deeply rooted to Assam through her works with Assam Foundation of North America, where she serves many leadership roles. And professionally also, she is very actively involved in various research projects related to related to mathematics, of course, and many research grants that she has initiated. And we are very delighted to have Dr. Deka with us today. Over to you now. Thank you so much for joining us.
Thank you so much for inviting me here. মই আজি কথাটো অসমীয়া আৰু ইংলিছ অলপ মিক্স কৰি ক'ম. So it's a pleasure for me to be here today, and hopefully you are joining from all across Assam or maybe outside, who knows. Today I hope to tell you a little bit about the kind of mathematics I am interested in. As you heard from Rifat, that I am a proud daughter of Assam. অসম গুৱাহাটীত ডাঙৰ হোৱা, গুৱাহাটীত জন্ম হোৱা, আৰু মোৰ ফেমিলি গোটেই গুৱাহাটীতেই থাকে। কামৰ কাৰণেই বহু বছৰৰ পৰা এতিয়া কেলিফৰ্ণিয়াত আছোঁ। কিন্তু অসমৰ নিজক এতিয়াও সদায় অসমীয়া বুলিয়ে ভাবোঁ, আৰু অসমৰ প্ৰতি থকা হোপফুলি আৰু এতিয়া বেছি কানেক্টেড হৈ থাকিবলৈ চেষ্টা কৰোঁ। মোৰ অসম ফাউণ্ডেশ্যন অফ নৰ্থ আমেৰিকাৰ প্ৰজেক্টবিলাকৰ থ্ৰুৰেও অসমৰ লগত কানেক্ট হৈ থকাৰ চেষ্টা কৰোঁ। চ' আজি আপোনালোকক মেথমেটিক্সৰ এটা পাৰ্টিকুলাৰ এৰিয়াৰ ওপৰত অলপ ইণ্ট্ৰডাকশ্যন দিম, আৰু মোৰ সেইটো এৰিয়া মোৰ ৰিচাৰ্চ এৰিয়াৰ মাজত পৰে। So hopefully you will like it. And if you have any questions, I'm happy to talk more about it. Keeping this talk more as an introduction to this field so that everyone can access it. I'm hoping that if you know a little bit about mathematics, you would be able to understand hopefully enough of it. And if you have a calculus background, then hopefully it will be a little bit more accessible. But, feel free to keep your questions. So I'm told that first I will go through the lecture slides, and then we can have any kind of questions. But if something comes up, please put it up on the chat so we can address those. So let me bring my slides with that. Let's see if this shows up. Is everybody able to see my slides?
Yes.
Okay. So I wanted to talk about counting. I know sometimes people think, we know how to count. We have been, counting all our lives. And maybe this is the reason every kid across the world are encouraged to learn math very early in their lives. Um, but I also want to tell you that counting is actually so much more involved than what we think of and how it is connected to today's world, our everyday world. It's kind of something that you can't even live one day without. So that's why I'm asking, do you really know how to count? So on a day-to-day basis, counting seems simple, right? All of us are doing some kind of counting somewhere during our day. But in mathematics and many, many applied field, you can be asked to count so many different type of things. So sometime if you hear questions like, how many different five-digit pins can you make? So PIN numbers, if you have a bank account or um, various other secure places to access, you need a PIN. Pins could be of any number of digits. So if I ask you a simple question, how many different pins can you make that have five digits in it? Suddenly it is so much more connected to your world, everyday world. And at the same time, maybe some of you know how to answer that. It's not as difficult, but again, the kind of questions that we want to think about. So other kind of questions can come about passwords. Our life nowadays is ruled by passwords. God knows each of you probably have so many different passwords that you're using. And that's connected to digital security and almost our over everyday security of our life because we are online so much for so many things. So here is a password questions. How many passwords of length 6 to 9 digit, 9 characters can be formed with characters including letters, digits, special symbols, that are on our phone, where no repetition is allowed. Suddenly it got a little bit more involved, right? Maybe some of you know how to answer that. Maybe you have no idea. So again, the kind of questions that we want to think about. Another question I want to throw in here is, which we'll discuss a lot more in this talk, how many standard young tableau with n boxes are there? Now, when you hear that, probably what are standard young tableaus? I don't know if any of you are aware of that, but if you are, it's a very interesting object. And again, suddenly, simple question, but we got to think a lot more, right? So it's not so obvious. So hopefully we will, by the end of the talk, get a feeling of or a flavor of how involved counting is. So, um, so why does counting matter? I think I already talked a little bit about it, but I wanted you to feel how it's connected to your everyday life, Every single one probably is on some sort of social media, probably buying stuff on Amazon, right? And other online venues. Also, like I said, passwords, probably all of us have a Google account, right? Or several ones. So number of possible passwords. And again, nowadays in the news and our lives are ruled by political news where they're always talking about how popular a certain personality is, whether it's a movie star or a politician. All of these questions are basically counting problems, because probability is basically a counting problem. And then, as I mentioned, data security and financial security are also involved. So many things about those fields are about counting. And then, of course, medical research and pharmaceutical research. When we had COVID and they were testing how efficient the vaccine is, bottom of the line was some sort of accounting, right? So a lot of real world problems. And in mathematics, we try to look at the problems, see some patterns, and create mathematical formulas or models to answer them. And because of this, one of the areas that is very much behind the scene is counting. And you probably also keep hearing a lot about data analysis nowadays, a field that is becoming very popular. A lot of it is about counting. So it's everywhere. So in this talk, we'll try to learn a little bit about how mathematicians count things, give you a little bit of a glimpse into what active research in this area called combinatorics look like, and why these questions matter, right? Why do we care about it? I mean, I know I care about them because it's just beautiful mathematics, but they are very relevant. And then I'll leave you with some references so that if this talk interests you in any way, you are able to get more information and reach out. So I don't know how many of you have heard of the word combinatorics. Maybe you all know all about it, but this is the art of counting, basically, the area of mathematics where counting is the main topic. And counting, or this world of combinatorics, became popular with puzzles and games, initially about, 7,500 years ago. But people originally wasn't taking this area of mathematics as seriously because it was connected to puzzles and games and more fun stuff. But with time, this field has become a very crucial tool to solve a lot of hard, complicated problems in various areas of mathematics. So the core ideas here, maybe some of you know about permutations, counting how many permutations are there, combinations, and many other counting principles, And one of the more generalized tool is also generating functions, a very important tool in mathematics that helps you to answer some of these questions in a more algebraic way. So I actually teach combinatorics class. It's one of my favorite topic to teach. And I teach it to not just mathematics students, but also computer science and statistics, because this is a core topic for them as well. So, counting is definitely a lot deeper than you might have thought about. So let's learn a little bit more. Here, before we get into a little bit more about the details of some counting problems, I just wanted to give you a glimpse of why does it get complicated? Why does it get tricky, Everyday counting, you are mostly listing numbers, you're figuring out, okay, what's the number for this particular counting and that particular counting. But in mathematics, when we are trying to count, we are actually trying to find not just in a particular case, we're trying to answer it for every case possible, right? So that means you need a mathematical general formula or a mathematical model that's going to help people answer the question in every scenario possible. So challenges arise from various kind of things. Most importantly, if the objects are new and defined by properties and restrictions, we need to understand what do they mean, right? So that creates the first-hand complication. But then we also want to answer it for every possible scenario, right? So more general formula. And with the really evolving computing power of computers nowadays, you can count or generate answers to a lot of these problems using programming. But in mathematics, that's not enough, okay? If you can just say, oh, here is the answer, you got to justify it. And a lot of the time, the hardest difficulty comes in that last one, where I have found a formula, but now I got to prove it mathematically, because if you haven't done that, it's not going to be, accepted as a true valid results or theorems. So there are all these various things that we will try to understand with a few examples, okay? So I wanted to start with a very simple counting problem in combinatorics. This is the one I put up earlier. How many different 5-digit pins can you make? So let's say your bank, to take money out from your ATM, you need to punch your pin, right? And the pin can be of various length. I'm just focusing on a 5-digit. And maybe all of you know already how many different pins. Hopefully you are not creating your pin as 1, 2, 3, 4, 5, you know. We need to create a pin that is more secure. So let's think about this as a mathematical problem. So here, you all know we have 10 digits, right? Starting in 0 up to 9. And we have a total number of 10 digits and 5 to pick, right? So pretty straightforward. First one, you have 10 options. Second one, they're not giving you any restriction here. It's a very simple one, meaning they don't care if you use 5 again, you know, the same number. So repetition is okay. So it's 10 times 10 times 10 times 10. So you have 100,000 possible passwords, pins here for this one pin that you need. And this is why I think you probably know that most ATM machines or bank don't allow you to punch more than 3 times or 4 times, right? Because they know if they allow you to punch it as many times, you can crack it, right? And if smart people with computing tools can pretty easily crack it. And that's why they're also making their pins longer as time goes. Originally, it used to be a 4-digit pin. Now most of them are using a 9-digit pin, you know, because, you know, to make it more secure. So this is a very basic counting problem, which is using product rule here to find the total number of possibilities. Hopefully this one makes sense to everyone. And again, well, there are lots of different counting methods and lots of interesting problems. But I'm going to focus on 2 problems in combinatorics that are connected to my research and the kind of work I do with my students. So I'm bringing this question, calling how many young diagrams are there with n boxes, right? Okay, question seems simple, but do we know everything in the question? So that's the first line of thinking that you got to start with. And nowadays that you have so many tools, you know, available to you, pretty easy to do the research on what young diagram means, you know, what are these objects. And then you can start getting into counting this. Now, when I say n boxes, n is a positive integer here, a number like 1, 2, 3, 4, 5, and so on. It could be pretty large, where that's why we're keeping it as an n. Okay, so n is a positive integer. So let's think about it, okay? So what do we need? So the first thing we need to understand is, what is a Young diagram? So in mathematics, we will represent a Young diagram with a lambda, is a Greek letter that we use. So this is a collection of boxes arranged in left justified rows, okay? Where the row lengths are weakly decreasing. So let's look at an example. So if my n happens to be 4, right? It could be 1, 2, 3, 4. If it happens to be 4, I will have, these are the Young diagrams that I can have. So I can have all my boxes in one row. These are rectangular arrays of boxes, but they must be left aligned. So that means every row must start at the same column, okay? So they're all left aligned, as you can see. So this is another way to put 4 boxes. Here is another way. Here is another way. And then you can see we can also put them all vertically. And then I kind of run out of more options. So in this particular case, n equal to 4, I got 1, 2, 3, 4, 5 different Young diagrams. So each of them is called a Young diagram, okay? So here we go. So that means we have a way of writing it. So we're going to write it as 4 for the 4 boxes in one row, 3, 1 for 3 boxes in the first row, 1 boxes in the second row, 2, 2, and hopefully you get the idea, okay? So we are going to represent these diagrams as this mathematical ordered pair. And as you can see, the numbers in the ordered pairs are increasing and then they are going down, okay? So that's what we mean by rows length are weakly decreasing, okay? So observation, I don't know if any of you know number theory. These pairs that we saw here, these ordered pairs, these are the partitions of the number 4 in number theory. So it simply means that these are the different ways you can break down the number 4 into positive parts, okay? So these are all of them. So that means in this case, answering my question is same as finding the number of partitions of that integer, okay? So one of the way to answer some of this question is to connect it to another field that is well known and bring formulas from that field and you're done. And in this case, we know what they are, okay? And I know that time is going quickly. I'm going to take a few more minutes to tell you about one more problem and then we can have more discussion. So in this scenario, how many young tableaus are there? Basically, same as the number of partition of that number, meaning how many ways can you break it down into, positive numbers, smaller positive numbers. Just so you know how this look. So for n equal to 1 to 8, these are all the possible Young diagrams. So each box here represents, this is the case for n equal to 1, this is for 2, this is for 3, and so on. And as you can see, it gets pretty big pretty quickly, okay? So the counting, that's how it becomes difficult. So we're going to look at one more question here about these particular diagrams, but now we're going to make it more interesting, okay? And this is what happens in the world of counting. You start with a simple one, then you keep bringing new restriction, new properties to it, and then you make new problems. So here's my new questions that we want to talk about. How many standard Young tableaus are there with n boxes? Now remember, first it was Young diagram. Now it is called standard Young tableau. It's a new object. And again, maybe some of you know about it, maybe you have no idea what these are, and that's perfectly okay. So I'm going to tell you, these are basically those Young diagrams. But in math, we never stop with just diagrams. We want to fill them up. So we're going to fill them up with numbers 1, 2, up to n. And here, the numbers have to follow 3 rules. Every number has to be only used once. They have to be increasing left to right and also top to bottom, okay? So let's look at an example. N equal to 5, and I'm picking one Young diagram, which has this breakdown. And here are the Young tableaus. So you see, we got the shape like we had before, and now we are filling it in. And these are all the different ways you can fill in this particular shape. So for every given shape, you are going to have some number of tableaus. And as the shape is going to change, you're going to have different number of tableaus, okay? Tableau is a French word for table, or, so it's just a fancy way of saying rectangular tables. In this case, not rectangular, but these fancy ones, okay? Now, this problem is actually quite complicated, but I wanted to show you just a simple case where your shape looks like an L. It's not quite an L, it's actually an upside down L. So here is a shape that we are looking at. This is how your Young diagram looks like, and we're going to fill it in with the 3 rules, okay? And we are looking at the particular case here for n equal to 4, okay? So, and then 2 L shapes. This for n equal to 4, I have 2 L shapes, one with 3 boxes in the first row and one on the second row, and then 2, 1, 1. And for each of these shapes, this is how the tables look, okay? I actually did it because this is a small example, and this is how you start this problem. Do some example in smaller cases. So in this case, I calculated it out for n equal to 4. So you can see I got 3 tables here and 3 tableaus here, and total of 6, okay? So in this particular case, we have 6. But this is just one case, right? So that's not enough answer. So we take that and we start making a table. This is where the data collection, a lot of time we would say in math. So I have a lot of students working on this kind of data collection where they can be using programming tools to generate this tables and then count them, in various levels. So in this case, I put a few. So the L shape for n starts at 3 because before 3, you can't quite have a L shape, right? So for n equal to 3, I get 2. N equal to 4, I get 6. N equal to 5, I get 14. And 30, do you see how the numbers are increasing? And it gets big pretty quick, okay? Kind of growing exponentially. But as you see this table, it kind of gives you a pattern. You're looking at these numbers. Now, is there patterns, And the pattern in this case comes out to be this function 2 to the n minus 1 minus 2, where n is the number of boxes in your shape. It's a pretty simple formula, right? So what I'm trying to show you that you generate enough data to see a pattern and then try to find a formula for that pattern. That's a very common way of looking at this kind of problems in combinatorics, okay? So, and then once we have this formula, we call it a conjecture, because we just got it from computation. And then we're going to have to prove it. In this case, actually, I don't know if any of you know math induction. This is a way of justifying formulas in math. So we can actually use math induction to prove this. Of course, there are other ways to do it too, but that's a very easy way. So this kind of gives you a flavor of how research goes. Of course, I try to pick a problem that's easy to navigate, but you can see the counting the standard Young tableaus for all shape is quite a wide and complex problem. As you can see, this here shows you, and you can see for n equal to 5, you see how many total. We only counted the L shapes. So this kind of gets pretty intense. So I just wanted you to understand how intense it gets. So if you look at this kind of shapes, I don't know if anybody can guess. I think this first shape is not hard. If you try to create the tables with numbers increasing along the row and increasing down the column, you can only find 2 for this shape. This one, it's going to take you some time. As you can see, the numbers grow pretty big pretty quickly, okay? So these are not simple problems, but they are super interesting. A lot of learning needs to happen behind the scene. Programming is a big tool. Pattern recognizing is the other one, and a lot of resources. So is there a formula? Actually, there is, but we would need some definitions, okay? Maybe I'll take 2 more minutes and then we'll go into questions and elaborate on more stuff. I have a lot more on this and happy to discuss. So to answer the formula, is there a formula for counting this objects called standard Young tableau? You need some definition. Maybe I will skip over a little bit so that I'll show you the formula. It kind of looks fancy. If you're not used to mathematical notation, could look scary, but it's doable. And it wasn't easy, but people kind of followed a similar methodology as we saw in the very simple problem, and they had to prove. There are lots of proofs of hook-length formula at all levels. I even had students who wrote thesis on simplifying this proof of this formula, and a lot of beautiful math involved. So these formulas basically calculate some numbers and then helps you to get plug it in and get. So what I wanted to say that standard Young tableau is kind of a new object maybe for some of you, but it's actually a very important tool in the world of combinatorics and the kind of research that I do. It has a lot of the connections in representation theory, branch of mathematics that has to do with algebra, and then quantum mechanics, a lot of physics questions. They have really complicated problem in their field, and they want them to be answered by a counting problem. And when you actually boil it down, it becomes counting a standard Young tableau of certain property. And that's why this particular tool is becoming a very important branch in the last 25 years or so. Before that, people were not seeing the connections, but with strong computing coming into our world, this is kind of bringing applied and pure math together branch. This is why I love it. And I can bring students from undergraduate level to do research on this. I was going to tell you more about open problems in combinatorics, which is what I'm working with some of my students. Um, these are proposed by the father of combinatorics, Richard Stanley, who is at MIT. He's now a professor of emeritus, but he has a lot of open problems, and we kind of look up to him to get new problems. And there are a couple of problems that we are working on. And if you want to know more about it, I would tell you in the discussion. But my slides do go through another question about counting in this, which is still open. I have worked with a couple of my students who are writing papers on this as well. Just wanted to give you a glimpse of a lot of the work involves calculating a lot of examples, and the examples get pretty intense pretty quickly. Doing by hand is almost impossible, so you need good programming tools. So I would usually have computer science student and math majors coming together to work on this stuff, so different people can do different things. And then once you get into formulas, it gets very interesting and a lot of connections. And we are able to see new results, new beautiful mathematics coming out of this kind of work. So I know it's kind of a fast moving talk, but I'm happy to answer a lot more questions and hopefully make you interested in this branch of mathematics. Here are some traditional books and journal paper that I really think could help you. This one, the book Mathematical Legacy of Richard Stanley, is a really interesting book if you want to understand. And I like this one, Combinatorics, The Art of Counting. These are the entry level. The Combinatorics Art of Counting gives you a flavor of this particular branch of mathematics very well. I use that with a lot of my students who are coming into the field. So feel free to Google up these references and reach out to me if you have any questions. I'm happy to answer. And here is my email, best way to contact me. Like I tell my student too, don't call me, just email me and I'm going to respond to you. So that's kind of like a quick intro into this world of combinatorics. And hopefully you at least got a little flavor of what it could look like and may think that counting is so much more and so much in your life. Just that we don't think about it when we are kind of on Facebook or Instagram. Everything involves counting some way or the other. So with that, I will end here and open for discussion and questions.
Thank you so much, Lipika, for this excellent talk on concepts about combinatorics and how it can be very interesting and how important it is. So that was really nice, and I think many students have probably have some questions about it for you. So, Moy, before we start the uh, QA session, I actually wanted to share quickly about our next session for our students so that they know about it. Um, can you see the screen? Oh, yeah. So actually, our next session is on September 21st, and we will have Dr. Shekhar Suman Bora, who is at University of Texas Tyler. So he's going to talk on a very interesting topic that is from transistors to memory stars, the fourth element of modern electronics. So hopefully students will be able to join. And back to Dr. Deka.
Yeah, I do see some questions on the chat. Should I answer those?
Yeah, please. Yeah, sure.
Someone's asking, how does combinatorics connect to modern fields like AI, computer science, and genetics? I think I mentioned a little bit, but I would say a lot. As you know, AI is uh, one of the core concept behind AI is data analysis and statistics, and a lot of use of discrete structures, and all of those involves a lot of counting. And like I said, I teach a class for computer science. For the topic is combinatorics, graph theory. I don't know if you've heard of graph theory. All of these fields are core concepts behind AI, creating AI and making AI more efficient and all of that. So it's very much a part of it. And genetics, of course, actually biology is a field where people are in genetics are counting, different kind of objects that are what we usually happens is they tell you this is what they're trying to count or trying to understand. Then we take that and convert it into a discrete structure, meaning one of the combinatorial tool like my young tableaus, that you saw. And then a lot of time it becomes about understanding, counting, doing things with those combinatorial objects, which brings back the answer that they are looking for or gives them insight into the kind of questions. So I say there is big connections. And nowadays, I also want you to know AI is everywhere and everyone's talking about it and everybody wants to get into that field. But one thing, it's more important to be behind the scene of creating AI than just using AI because there are two sides, right? You are either just using AI to do more things. That's one part. But people who are actually creating the AI, like the OpenAI company people, and they are the one who needs all of this behind the scene mathematical and statistical background to become better at creating the AI rather than using the AI. So if you're interested in that side of AI, you definitely have a lot of connections. Hopefully that answers that question. Any follow-up on that?
Now, Belagata question, maybe you see it that I saw it.
Yeah, the next question to my Dekisu, why is combinatorics important for someone who may not go into pure math, say a biology or economics student? Very good questions. As you saw in one of the slide, I said one of the application field is financial security and banking is another big one. And economics, actually, when you talk to a mathematician at the high level, there is very less difference between economics and mathematics. And I'm sure Hiranunat will agree with that. You need a lot of mathematics to be able to do economics. So, and biology, as I said, a lot of the biological research now uses a lot of statistical tools, which involves a lot of counting because, finding probability in a lot of times is just about counting the set of objects that you are looking at. So definitely, you don't have, this is actually a branch which is, as I said, intersection of pure and applied. The tools are very applied, but the questions could come from anywhere, right? So that's why I feel like it's a good mathematical topics if you're thinking of going into applied field. আৰু এটা question দেখিছো ইয়াতে. So is combinatorics all about formulas? Can you please simplify? No, it isn't just about formulas. So I picked the counting problem whose answers are formulas because I thought that would be good for this audience, which is could be wide range of background. But combinatorics has a lot of theoretical questions as well. In fact, once you get the formula or do the computation and you have a conjecture, you have to prove the conjecture. And that has nothing to do with formulas. Then you need to go back and actually use mathematical tools to justify your answer. Also, and then the two books that I have mentioned would actually show you a lot more about combinatorics, and I'm happy to respond more about that as well. Yeah, it's not just about formulas, but that's the easy way to bring people into this field.
আৰু কাৰোবাৰ কিবা প্ৰশ্ন আছে নেকি ডিৰেক্ট গ্ৰুপত বহুতো আছে আমাৰ গ্ৰুপৰ মেম্বাৰো আছে পৱন চহৰীয়া ছাৰ আছে ছাৰ আপোনাৰ কিবা কুৱেশ্যন আছে
নাই মোৰ একো কোৱাচোন নাই দীপিকা দেখা পাই খুব ভাল লাগিলে মই
নমস্কাৰ ছাৰ।
নমস্তে মই তোমাৰ লেকচাৰটো শুনিবৰ কাৰণে মই এঠাইত গৈছিলো লৰালৰিকে আহিছো
থেংক ইউ ছ' মাচ। ভাল লাগিল দেই আপোনাৰ মাতটো শুনি।
বৰ ভাল লাগিলে তোমাক বহুত দিনৰ মূৰত দেখিলো মোকো এবাৰ দেখাই দিছো ৰবা অলপ
প্লিজ ছাৰ তাকে
দিছে ভিডিঅ'টো অন কৰিছো দেখিছানে নাই
বাপৰে মই কবই খুজিছিলো আপুনি ভিডিঅ'টো অন কৰিব নেকি। আপুনি পিছে একে আছে দেই, একো সলনি হোৱা নাই।
নহয় নকবা তেনেকে থেংক ইউ মই বোলো ঠিক আছে নহয় তোমাৰ বাইদেউৰ ঘৰৰ কাষতে যে মোৰ কাষতে থাকে বোধ কৰো হেৰেন্দৰ ৰিফাতহঁতে নাজানে
হয় নেকি? আপুনি মানে হেৰি আমাৰ নৱনীতা বাইদেউৰ কথা কৈছে।
বনিমা
অকে 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 গম পাইছো। তাকে
বনিমা তোমাৰ বাইদেউ নহয় জানো
নহয় মানে চিনি পাওঁ আৰু বাইদেউ বুলিয়ে ধৰক আৰু, কিন্তু মানে
অকে অকে
একো নাই
মই
তাকে। ভাল লাগিল দেই। তাকে ময়ো মানে আপোনালোকৰ হেৰিবোৰ চাই আছিলো, ভিডিঅ'বোৰ মাজে মাজে চাই থাকো। মাতাৰ কাৰণে ভাল লাগিলে আৰু আজি কথা কৈ।
কিন্তু ভাল লাগিলে তুমি যে তাত আছে এনেকে ইমান ধুনীয়াকে ফুল প্ৰফেচাৰ হৈ খুব ভাল লাগিলে
থেংক ইউ।
লেকচাৰটো মই শুনিলো আৰু বিশেষ আমাৰ ভিতৰৰ বস্তু নহয় তথাপিতো ইমান ডাঙৰ কমপ্লেক্স ফিল্ড এখন
তাকে আজিকালি মানে ইটছ আ ভেৰি কম্পিউটেশ্যনেল ফিল্ড এণ্ড ইটছ আ ভেৰি মানে গুড ইণ্টাৰছেকশ্যন অফ মেথ এপ্লাইড এণ্ড পিয়ৰ। তাৰমানে মই যেতিয়া PhD কৰিব গৈছিলো, my area is algebra, but in algebra the problems মানে representation theory problemবোৰ we were able to use combinatorial tool to solve it. So that field is called algebraic combinatorics. So you're solving
It is abstract algebra or just linear algebra?
no abstract algebra.
Abstract algebra.
So representation theory হৈছে আপোনাৰ basically infinite group finite and infinite groupৰ ওপৰত মানে you create a vector space structure and then you count how many different irreducibles you can have, and there actually the Young tableaus counts the number of irreducible representation for symmetric group.
Okay.
That's where the connection started. And then now there are so many connections. It's like a very evolving field of research. Yeah.
Definitely very important to this one. Okay.
সংঘমিত্ৰা তোমাৰ কিবা প্ৰশ্ন আছে নেকি
তাকে সংঘমিত্ৰা ৰাতিপুৱা আহিছে উঠি
প্ৰশ্ন আছে এনি কুৱেশ্যন সংঘমিত্ৰা
নাই মই নাই কিন্তু মই থেংক ইউ ছ' মাচ লিপিকা মই অলপ শুনিলো বহুত ভাল লাগিলে ইমান বুজি পোৱা নাই
I know.
Yeah, but I introduced you a new topic, so
that's good. Yeah, I think that's the idea, because we are always used to certain types of math, but we don't hear about all this new field which have so much connection to computer science and AI and statistics. And I feel like students like these topics more now because it also is better for their job opportunities, if they don't want to be a math teacher or go to graduate school. So a lot of our students are showing a lot of interest in this kind of topic. So
yeah, but I worked with I'm working with graph theory.
Oh, there you go.
Yeah, so nice to
lots of combinatorial problem in graph theory. That's one of the topic I teach within the combinatorics class. Yeah.
Right, because of AI, like all the traditional structure of the data has gone, right? Now people are more focusing on graph-based databases. So we have to create that.
I know. So yeah, actually, we teach at a graph theory class at our because graph theory is like, for me, it's just beautiful, but also very relevant.
Yeah. So we use it to structure our data, so Neo4j and stuff like that.
That's nice, yeah.
Yeah.
I know. So behind everything is mathematics, right? So we phone, social media kori thake na bhabe, but there is so much math behind it.
Right. And logic.
And of course, a lot of this
Yeah.
class actually starts with logic because you
Right.
without logic.
Sure.
Yeah. Now, তাৰমানে কম্পিউটাৰ চায়েন্স ষ্টুডেণ্টক যেতিয়া মেথ পঢ়াবলৈ যাওঁ, ফাৰ্ষ্ট কুৱেশ্যন ইজ আমি এইবোৰ কিয় কৰিব লাগে, এইবোৰ আমি ক'তো ইউজ নকৰোঁ।
Right.
A very hard student group to teach because they come just because they have to do it. And then, I feel very good that by end of the semester, some of them become math majors because they love the class so much and they saw the beauty in it and connection. So, yeah.
Right. So, Lipika, not like in near future, if you can give a talk on applied math, like there are some Berkeley data courses, applied math, UCL আছে মই সব ক'ত আৰু নাজানো কাৰণ মই তাত আছে বুলি জানো কাৰণ মই কিছুমান মানুহ জানো মানুহবিলাকে নাজানে what is applied math. So, if you can like
Definitely, yeah. We can definitely talk. A graph theory would be a good topic, I think, in applied math. It's one of the, and yeah, definitely. I'm happy to talk more about. Actually, in my sabbatical, one of the things when I'm trying to do is how to make our pure math program to have more applied topics. Because mathematics as a pure field, although we love it, and it breaks my heart, but it's becoming less popular than and হিৰণদাই হয়তো দেখিব যে pure sciences বিলাক এতিয়া less popular হৈছে কাৰণ obviously practical reasons চাকৰি কম আছে, right, all that, and so we want our student to be not feeling like we don't have the tools, right? So সেইকাৰণে আমি we're trying to bring a lot more applied math into the program so that student bilake can sell them also as, see, you need the problem solver behind all of this. A lot of companies are hiring math major who have very good problem solving skill with all this, like computing, and as you can see, more to research or Harry, I need programming. I am a pure mathematician, but I make my student do the programming. And now AI can do the programming. I'm developing a math modeling class during this sabbatical where a lot of the problems are coming from to me jeneke koisa different fielder pora, and then we are kind of teaching them how you're going to make it into a math problem and provide answers, right? So
yeah. Thank you.
Yeah.
Hiranyada, anything you wanted to add related to economics also? There is a lot of talk.
Thank you, Lipika. বৰ সুন্দৰকে তাৰমানে তোমাৰ প্ৰেজেণ্টেশ্যনৰ টাইটেলটোৱে খুব থট প্ৰভোকিং আছিলে। আমি আচলতে গণিব জানোনে সেইটো এটা খুব থট প্ৰভোকিং প্ৰশ্ন। খুব ভাল লাগিল তোমাৰ কথাখিনি। মোৰ দুটা নহয়, মই প্ৰশ্ন কৰিয়ে গৈ থাকিব পাৰোঁ, কিন্তু এটা ইকনমিক্সত যিটো ৰিলেট কৰা হয় সাধাৰণতে, আৰু তাৰ লগত তুমি আজি যিটো প্ৰেজেণ্টেশ্যন দিলা তাৰ সম্পৰ্ক আছে, সেইটো হৈছে নেটৱৰ্কিং থিয়ৰী। গতিকে নেটৱৰ্কিং থিয়ৰী আৰু কম্বিনেটৰিক্সৰ অকণমান তুমি হেৰিটো কানেকশ্যনটো এই ল'ৰা ছোৱালীবিলাকে নিশ্চয় নেটৱৰ্কিং থিয়ৰী, এতিয়াতো ফোন ইণ্টাৰনেটৰ যুগত নেটৱৰ্কিং থিয়ৰীটো এক্সটেনচিভলি বিভিন্ন ফিল্ডত ব্যৱহাৰ কৰা হয়, গতিকে অকণমান কানেকশ্যনটো কৈ দিবা নেকি?
Sure, yeah. So actually, networking is a part of, in a way, I think of networking in mathematics as a part of graph theory. So basically, যদি simple wordত কৈছো, যোনে মানুহে ভাবিব পাৰে what is networking. So one way to think about কি আজিকালি আমি যে ইউনিভাৰ্চিটি বিলাকতে থাকো, right? চবৰে কম্পিউটাৰ আছে, চবৰে ফোন আছে, but sobore internet connection ase, right? So the whole university has created this networking system that provides free Wi-Fi to every computer and every phone. Sobore etatke beshi computer thake, right? Desktop thake, laptop thake, and so on. So what they're doing is they have basically a server that they put, in different places in the university that connects to all the devices. So the servers are basically your dots in the network, and the connection is your edge, you know. So if my laptop is connecting to this particular Wi-Fi at this particular server location, that's your edge. So you have dots and edges, which is your graph, basically what Sanghamitra was talking about. So now one of the questions, simple question, maybe this audience can understand is, what you do is you take your network and you convert it into a graph with dots and edges. And then one of the question is, what is the most efficient way to place your dots in the campus, right? So that everybody will have the perfect Wi-Fi connection. I don't know if this is sort of connecting to economical problems.
Wherever there is efficiency, there is economics.
Exactly. So in your case, it could be some financial where dots could mean something else and edge could mean something else. But this is one of those networking problem. And so how do you create a very efficient network, right? So that means you need to, in a way, if I'm thinking about counting, যদি মোৰ 10টা server আছে আৰু let's say 100,000 মান device আছে, you can already think it's a very big network. So you
Yeah.
want to figure out what's the most efficient way to place your server within this area so that all of your 100,000 devices or 100,000 devices can have the good connection. So that's where the efficiency comes. So now the efficiency is also about speed, right? How fast you can, or distance, right? Or where should you, like some offices get better connection than some other offices in the campus, right? So the efficiency factor is converted as a number. So you're going to get a weighted graph, you know, dots and lines, and each line will have a number on it, which is the weight on that, which is the efficiency factor. And then you need to write down all possible network and pick the one that has the best efficiency number, right? And that will give you an efficient network. Again, as you can see, it's a lot of generating different example and then counting, right, and finding. And there are many algorithms which does it. And those algorithm precisely uses counting methods and going around figuring out. So yeah, I don't know if that gives you a flavor of what some of this problem could look like, but
Economicsত আজিকালিৰ মানে যেটো টেকনলজি ICT ইনফৰমেশ্যন এণ্ড কমিউনিকেশ্যন টেকনলজি
there you go, yeah.
particularly developing country কনটেক্সটত হয় কি প্ৰথমতে ধৰা 100 জনক স্মাৰ্টফোন দিলা তাৰ পিছত 200 জনক দিলা 1000 জনক দিলা তাৰ লগে লগে নেটৱৰ্কটো যিমানেই ডাঙৰ হৈ গৈ থাকে মাৰ্কেট এক্সেছটো বাঢ়ি গৈ থাকে নহয় গতিকে ইকনমিক্সৰ ফালৰ পৰা এটা কোম্পানীয়ে কেনেকৈ মাৰ্কেট এক্সেছটো পায় বা মানুহে কেনেকৈ বিভিন্ন বস্তুৰ এক্সেছটো পায় সেই কথাটো মানে নেটৱৰ্কৰ কথাটো আহে ইকনমিক্সত
Yeah, yeah, in a way, we are talking about the same thing. Scenario is different. So in your case, the dots and edges are going to be different. So yeah, but the concept, because when you actually boil it down to a math problem, they would look the same, whether it comes from a wireless network or a economics network, you know. So that's how these problems, that's where the math come behind both areas. So
যিবিলাকে মাৰ্কেট ৰিচাৰ্চ কৰে বা কোম্পানীবিলাকক এডভাইচ কৰে যে মানে মই এই হেৰিটোৰ ৰেলিভেণ্ট যিটো প্ৰেক্টিকেল ৰেলিভেন্সটো ল'ৰা ছোৱালীয়ে কেনেকৈ বুজি পাব সেইটো ক'বলৈ এতিয়া কোম্পানীবিলাকে বহুত তেনেকুৱা মানুহ হায়াৰ কৰে যিবিলাকে সেইটো ফিগাৰ আউট কৰিব পাৰে যে নেটৱৰ্কটো কিমান গতিকে মাৰ্কেট এক্সেছটো কিমান পাব সেইটো প্ৰসংগত মানে নেটৱৰ্কিং থিয়ৰিটো ব্যৱহাৰ কৰে মাৰ্কেটিঙত কৰে ইকনমিক্সত কৰে মোৰ ছেকেণ্ড কুৱেশ্যনটো হৈছে তোমাৰ তুমি বহুত মেথ এডুকেশ্যনৰ ওপৰতো কাম কৰা বুলি আৰম্ভণিতে কৈছা গতিকে একদম সাধাৰণ প্ৰশ্ন মেথমেটিক্স আমিও পাওঁ এতিয়া ল'ৰা ছোৱালীবিলাক যেতিয়া ইকনমিক্স পঢ়িব আহে বা অন্য ছাবজেক্টবিলাক পঢ়িবলৈ দে আৰ নট ভেৰি well prepared like in terms of their math skills or in terms of their মানে math preparedness to সেইটো অকল মানে আমাৰ দেশতে নহয় ইউএছতো সেইটো প্ৰব্লেম আমাৰ দেশত মানে ভাৰতবৰ্ষলৈ গ'লে অসমলৈ গ'লে সেই একেটা কথাই শুনা যায় মেথ এডুকেশ্যনটোত মানে কি ধৰণৰ সমস্যা আছে বা কি ধৰণৰ কাম কৰিলে তোমালোকে যেতিয়া যে এজ এ মেথমেটিচিয়ান যিবিলাক চিন্তা চৰ্চা কৰি আছা বা সেই ফিল্ডটোত কাম কৰি আছা কি কামবিলাক কৰিছা অকণমান এটা আভাস দিবা নেকি কাৰণ মই দেখিছোঁ যে ফেচবুকত আমাৰ কিছুমান ছায়েন্স মেথ টিচাৰ আছে গতিকে তেওঁলোকৰ হয়তো এই প্ৰশ্নটো জাগিব পাৰে যে আমি কি কৰিলে ল'ৰা ছোৱালীবিলাকৰ কাৰণে মেথটো ইণ্টাৰেষ্টিং কৰিব পাৰোঁ বা তেওঁলোকৰ এই মেথ ফবিয়াটো নাথাকে
Yeah, very, very good question and very relevant. আৰু সেইকাৰণে মানে মোৰ এতিয়া এই 20 বছৰ কেৰিয়াৰ এতিয়া মানে আই এম ফ'কাছিং এ লট অন মেথ এডুকেশ্যন কাৰণ ৰিচাৰ্চ কৰি আমি কিমানজন মানুহক ইনফ্লুৱেঞ্চ কৰিব পাৰিম কিন্তু টিচাৰ হিচাপে মেথ টিচাৰ হিচাপে যদি আপুনি মেথ টিচাৰ হয় আমি জানো কিমান ধৰণৰ ষ্ট্ৰাগল আৰু একে ষ্ট্ৰাগল ইয়াতো আছে আৰু মই আপুনি যে কৈছে অসমৰ বা ইণ্ডিয়াৰ ইয়াতে আমাৰ লট অফ ৱৰ্ক হেপেন্স উইথ আৱাৰ বিজনেছ স্কুল বিকজ আপুনি যিটো কৈছে বিজনেছ স্কুলৰ সদায় কমপ্লেইন মেথছৰ এইটো নোৱাৰে সেইটো নোৱাৰে এইটো নাই ইউ ন' so we are always we have actually now designed special class for business math for business you know and as a lot of the universities here do so আমি কি কৰিছোঁ তাৰমানে মই বহুত ধৰণৰ কাম হয় বাট এটা কথাৰ ওপৰত ফ'কাছ কৰি কৈছোঁ চ' মেথছ মানে কি হৈছে এতিয়া US-ত ট্ৰেডিশ্যনেলি যেনেকৈ আমি মেথ পঢ়াইছিলোঁ সেনেকৈ আমি নপঢ়াওঁ এনিমৰ তাৰমানে এতিয়া যদি আপোনালোক মোৰ ক্লাছৰুমলৈ আহে মই লেকচাৰ দি নাথাকোঁ তাৰমানে চ' লেকচাৰ দিওঁ বাট ফাৰ্ষ্ট থিং হৈছে ইন'ভেটিভ ৱে অফ টিচিং so you engage the student মানে বহুত it's more like a discussion একেলগে বহি কথা পাতি প্ৰশ্ন এনচাৰ কৰি পঢ়া যায় so সেইটো মানে হৈছে এটা big change in teaching methods so that's one thing that I work a lot on and মই যেটো কৈছো there are different ways to do that তাৰমানে group work flipped classroom বহুত ধৰণৰ আছে so সেইটো কৰাৰ ফলত মানে কি হয় বিকজ আমাৰ বহুত ষ্টুডেণ্ট আছে যোনে একজেক্টলি মানে প্ৰিপেয়াৰ্ড নহয় কলেজত আহিছে যদিও এতিয়াও মানে ফ্ৰেকশ্যনৰ কামো কৰিবলৈ দিগদাৰ হয় সিহঁতৰ মানে বেচিক এলজেব্ৰা স্কিল প্ৰব্লেম হয় আৰু মেথছত একদম ইণ্টাৰেষ্ট নাই এণ্ড লট অফ এনজাইটি ইজ লাইক মেণ্টেল হেল্থ এণ্ড এনজাইটি এবাউট মেথ আই এম চিয়'ৰ ইটছ ইন অল ফিল্ড বাট পষ্ট ক'ভিড আৰু বেছি হৈ গ'ল তাৰমানে বিকজ ডিউৰিং ক'ভিড ল'ৰা ছোৱালীবিলাক স্কুলত বহুত ডিষ্টাৰ্বেঞ্চ হ'ল ৰাইট ইন দেয়াৰ চ' দেৰ ইজ এ লেক অফ লাৰ্ণিং so at a project that I am funding right now, I have a grant that I'm wrapping up. So teaching method to সলাবলৈ বহুত innovation চলিছে so আমি হেনেকুৱা বহুত ধৰণৰ কৰিছো to engage the student more it's not like one way teaching it's a both way it's like an interactive teaching বহুত ধৰণৰ বেলেগ ধৰণে কৰা হয় but the other new thing that is going on is called alternate grading এই অলপ আগতে আপুনি কৈছিলে নহয় খালি পৰীক্ষাই হৈ থাকে পঢ়ে কেতিয়া ল'ৰা ছোৱালী আৰু পৰীক্ষা is creating বহুত এনজাইটি ক্ৰিয়েট কৰিছে আমাৰ ল'ৰা ছোৱালী কাৰণে মানে ল'ৰা ছোৱালী পঢ়াৰ ইণ্টাৰেষ্ট নাই আৰু অংক বুলি ক'লেতো আৰু ইণ্টাৰেষ্ট নাই so alternate grading হৈছে মোৰ প্ৰজেক্টটো আমি ক্যালকুলাস লেভেল ক্লাছবিলাকত কৰিছোঁ তাত তাৰমানে আমি পৰীক্ষাবোৰ ট্ৰেডিশ্যনেল নহয় য'ত তুমি কুইজ ল'ব যোৱা বা এক্সাম হয় 2 ঘণ্টাৰ এনেকুৱা নহয় চ' ল'ৰা ছোৱালীক তাৰমানে কিবা এটা পৰীক্ষাত বেয়া কৰিলে ফেইল হৈ নাযায় বা নেগেটিভলি ইম্পেক্ট নহয় চ' গোটেই ক্লাছটো ক্যালকুলাস টু ডিভাইড ইনটু 10 or 25 learning outcome মানে ক্যালকুলাস পঢ়িলে এইগিটা বস্তু তুমি জানিব লাগিব very precisely যে তুমি যদি ক্যালকুলাস ক্লাছটো পাস কৰিছা এই 20টা বস্তু কৰিবলৈ তুমি জানিব লাগিব আৰু আমি তেতিয়া কি কৰো পৰীক্ষাবোৰ সেই 20টা বস্তুৰ ওপৰত হয় তাৰমানে যে মই ডেৰিভেটিভ ক্যালকুলেট কৰিব পাৰো এক্সাম্পল এটা দিছো এনেকুৱা ধৰণৰ ফাংচনৰ কাৰণে সেইটোৰ ওপৰত প্ৰশ্ন কৰা হয় আৰু ল'ৰা ছোৱালীয়ে তাৰমানে প্ৰত্যেকটো লাৰ্নিং আউটকাম মানে সেমেষ্টাৰটোৰ ভিতৰত পাছ কৰিব লাগে এতিয়া আপুনি একেটা লাৰ্নিং আউটকাম বহুতবাৰ ল'ব পাৰে তাৰমানে so that's the new approach আগতে যেটো আছিল এটা পৰীক্ষা ললে তাত যদি বেয়া হ'ল হেনা যদি মই গা বেয়া হৈ আছিল কিবা হৈ আছিলে ইউ আৰ পেনালাইজ ইউএছত মানে এছেছমেণ্টটো বহুত ফ্লেক্সিবল হয় এইটো মানে ইটছ ব্ৰিঙিং এ ডিফাৰেণ্ট লেভেল অফ ফ্লেক্সিবিলিটি উই আৰ ফ'কাছিং কি ল'ৰা ছোৱালীবিলাকে একচুৱেলি বস্তুটো শিকিছে নে নাই নট এবাউট জাষ্ট পাছিং বাট কনচেপচুৱেল আণ্ডাৰষ্টেণ্ডিং হৈছে নে নাই চ' ৰেপিটেডলি কেইবাবাৰো একেটা বস্তুৰ ওপৰতে পৰীক্ষা লয় তাৰমানে আৰু সেইটোত ফ্লেক্সিবিলিটি থাকে ক্লাছত ল'ব পাৰে বাহিৰত ল'ব পাৰে এটা ফেইল কৰিলে আকৌ আহি নেক্সট টাইম ল'ব পাৰে চ' সেই যিটো অল্টাৰনেট ৱে অফ ইটছ কল এফিচিয়েঞ্চি গ্ৰেডিং তাৰমানে অৰ ষ্টেণ্ডাৰ্ড বেছ গ্ৰেডিং মাষ্টাৰী গ্ৰেডিং এইবিলাক ৱৰ্ড আজিকালি খুব ইউজ হয় মানে কনফাৰেন্সৰ পৰা আহিলোঁ ইজ বিকামিং বিগ নাও লট অফ ফাণ্ডিং কামিং ইন টু দিছ কাইণ্ড অফ এপ্ৰ'চেছ আৰু এইটো কি হয় মানে এই যিটো প্ৰিচাইচলি মেণ্টেল হেল্থৰ কথা কৈছোঁ আৰু ষ্টুডেণ্ট হু আৰ নট প্ৰিপেয়াৰ্ড সিহঁত যেতিয়া স্কুলত মানে পৰীক্ষা লয় বহুত এনজাইটিৰ কাৰণে জানিলেও পৰীক্ষাটো বেয়া হয় তাৰমানে চ' এইটোত কি হৈছে ষ্টুডেণ্টে আমাক উই হেভ ডান আ লট অফ ফ'কাছ গ্ৰুপ অফ ষ্টুডেণ্ট আণ্ডাৰষ্টেণ্ডিং কি হাউ ইটছ ৱৰ্কিং ফৰ দেম সিহঁতে কৈছে যে ইটছ হাৰ্ডাৰ কাৰণ এতিয়া পাৰ্চিয়েল ক্ৰেডিট লৈ পাছ কৰিব নোৱাৰে তাৰমানে পূৰা বুজিব লাগিব which is what we want, right? But it's not stressing them out because সিহঁতে জানে যে আজি যদি মই ফেইল কৰোঁ দুদিন পিছত আহি মই আকৌ এইটো পৰীক্ষা ট্ৰাই কৰিব পাৰিম ডিফাৰেণ্ট প্ৰব্লেম হ'ব বাট ছেইম কনচেপ্ট একেটা প্ৰব্লেম নাহে এভৰি টাইম ইউ জেনেৰেট এ নিউ ছেট অফ প্ৰব্লেম চ' দিছ ইজ ওৱান ৱে অফ ডুইং অল্টাৰনেট গ্ৰেডিং যিটো আমি মোৰ গ্ৰাণ্টটোৰ থ্ৰুৰে আমাৰ গোটেই ইউনিভাৰ্চিটিৰ এতিয়া অল কেলকুলাছ level classes are now in this method. So all of my instructors are teaching in this method. আৰু জানিব যে ইয়াতো তাৰমানে পাছিং পাৰ্চেণ্টেজ বহুত ভেৰি কৰে আৰু এই আৰ্লি লেভেল ক্লাছবিলাকত কলেজত পাছিং পাৰ্চেণ্টেজ বহুত কম হয় তাৰমানে 50%তকৈ কম হয় আমাৰ মেথডটো ইজ শ্বয়িং মোৰ দেন 80% পাছিং ৰেট তাৰমানে on top of that it's also showing ki ebilak students are getting interested in the math rather than just passing it so
হেল্ল'
oh,
হেল্ল'
sir.
হিৰণ্য সুধিবা আৰু না মই হেৰি দীপিকা এই কথাটো খুব ভাল লাগিলে এই যে অল্টাৰনেট ৱে অফ গ্ৰেডিং হা চ' এই বিষয়ে তুমি এটা আকৌ পিছত আৰু এটা টক দিব লাগিব আমাৰ এই হেৰিত হা
definitely
যে
sir
এইটো সঁচাকে
definitely connect কৰিলে হ'ল মই actually অসমলৈ আহি আছো যদি ক'বাত ক'ব লাগে I'm happy to talk about
নাই এইটো
বহুত
আচলতে টিচাৰ বিলাকৰ মাজত ষ্টুডেণ্টৰ সলনিও এইটো আচলতে টিচাৰ বিলাকৰ মাজত এনেকুৱা এটা টক হ'লে খুব ভাল হয়
Exactly. আমি এইটো প্ৰফেচনেল ডেভেলপমেণ্ট বুলি কওঁ আমি এতিয়া এজ এ ইউনিভাৰ্চিটি আমি বহুত লোকেল স্কুলবিলাকৰ লগত কাম কৰোঁ তাৰমানে চ' উইথ দিছ গ্ৰাণ্টছ আৰু সেই স্কুলবিলাকত মানে টিচাৰবিলাকক হেল্প কৰোঁ কেনেকৈ তাৰমানে কনভাৰ্ট কৰাটো সহজ নহয় ৰাইট বহুত সময় লাগে আৰু মাইণ্ডছেট চেঞ্জ হ'ব একচুৱেলি মোৰ গ্ৰাণ্টটোৰ বিগাৰ থিং ৱাজ অলছ' to change the teacher's mindset কাৰণ আমি ভাবোঁ যে ট্ৰেডিশ্যনেল একদম হাৰ্ডক'ৰ 3 ঘণ্টা পৰীক্ষা নিদিলে মানে we are making it easier for them কিন্তু হয়নে সেই বস্তুটো ইয়াতো আছে প্ৰফেচাৰবিলাকক we had to convince them a lot so the data কি actually student learns better and retain the information সেইটো বৰ ইম্পৰ্টেণ্ট ৰাইট আপুনি আজি শিকি আমাৰ যিটো আছিলে আগতে আজিকালি হোপফুলি ইণ্ডিয়াত সলনি হৈছে কিন্তু আমাৰ দিনত আছিল ল'ৰা ছোৱালীবিলাকে একমাহ খুব পঢ়ে পৰীক্ষাৰ আগত আৰু পৰীক্ষাত ভাল কৰে তাৰপাছত একো মনত নাথাকে পাহৰি যায়
একেই আছে ছেম চিষ্টেম এতিয়াও আছে হা এতিয়াও আছে মই আৰু এটা কথা সুধিব খুজিছো হা হিৰণ্য কিবা সুধিবা নেকি মই সুধিব পাৰো
নাই ছাৰ সুধি থাক আপুনি সোধক
হেৰি লিপিকা হা হেল্ল' নাই মই আৰু এটা কথা মানে আজি কেইদিনমান আগতে 3-4 আগতে মঞ্জুল ভাৰ্গৱে এটা লেকচাৰ এটা দিছিলে হা এই ইণ্ডিয়াত মই লেকচাৰটো পুৰা শুনা নাই যদিও মই গোটেই কথাখিনি মানে পঢ়িছো হা তেখেতে এটা কথা কৈছিলে যে এই আমাৰ প্ৰত্যেকটো কালচাৰত ইণ্ডিয়াই হওক বেলেগ বেলেগ কালচাৰত যিমানবিলাক পুৰণা মেথমেটিক্সৰ মেথড আছে so if a student does not learn all those methods and their cultural roots so they will not be good mathematicians so what is your comment
So, sir, মই নিজৰ এক্সপিৰিয়েঞ্চ এটা আপোনাক কৈছোঁ দেই চ' মই যেতিয়া কেম্ব্ৰিজলৈ গৈছিলোঁ মোৰ যিজন মানে কেম্ব্ৰিজত কি হয় আপুনি ডাঙৰ ডাঙৰ ক্লাছ লয় আৰু এজন আপোনাৰ মানে প্ৰত্যেকটো ছাবজেক্টৰ কাৰণে এজন মানে প্ৰফেচাৰক এডভাইজাৰ কৰি দিয়ে আৰু সেই তেওঁৰ ওচৰত আপুনি যাব লাগে মানে সপ্তাহত এবাৰকৈ 2 ঘণ্টা টিউশ্যন কৰিবলৈ মানে আমাৰ ৱৰ্ডত চ' সেই প্ৰফেচাৰজনে মোক এইটো কমেণ্ট দিছিলে আফটাৰ ৱৰ্কিং উইথ মি ফৰ আ মান্থ চ' দুটা ষ্টুডেণ্ট যায় চ' তেওঁ সদায় কয় যদি থিয়ৰী জানিব লাগে লিপিকা সোধা চি ন'জ অল দ্য থিয়ৰী অ'কে একদম মানে যি নুসুধক আৰু মেথছৰ চব জানো কিন্তু এপ্লিকেশ্যন কৰিব দিয়ক একো নাজানো তেতিয়া চ' মই যিটো মেথছৰ এডুকেশ্যন লৈছিলোঁ তাৰমানে বহুত থিয়ৰিটিকেল আছিলে আমি ধৰক এতিয়া 100-200 বছৰ পুৰণীয়া 800 বছৰ পুৰণীয়া থিয়ৰমটোৰ প্ৰুফ লিখিব দিয়ে পৰীক্ষাত অ'কে ৰাইট দ্য প্ৰুফ অফ দিছ থিয়ৰম হাৰে সেইকাৰণে
Okay.
মুখস্থ কৰি যায় আৰু প্ৰুফটো লিখি দিয়ে ৰাইট চ' কিন্তু প্ৰুফটো এপ্লাই কেনেকৈ কৰিব লাগে নবডি ন'জ চ' এই কমেণ্টটো মই ক'ম যে এইটো ইম্পৰ্টেণ্ট টু ন' অল অফ দেম বাট it's also important to learn the application because এতিয়া মানে
Okay.
application নকৰাকে ইয়াত মানে কি হয় westত it's very application oriented so yeah তেখেতৰ কথাটো এইটো হয় যে to have strong conceptual understanding you need to know all of the main results and where they came from so you can make the connection
Yeah.
but it's important to learn the application আমাৰ তাত আজিকালি পঢ়াই নে নাই নাজানো কিন্তু এপ্লিকেশ্যনটো এটলিষ্ট একদমেই পঢ়োৱা নহৈছিলে আমাৰ দিনত আৰু সেইটোৰ ফলত মানে বহুত চাফাৰ কৰা হৈছিলে ইভিন দো আই হেড ভেৰি ষ্ট্ৰং থিয়ৰী নলেজ
আৰু লিপিকা সেইটো এটা
নাজানো এইটো
bottleneck
আপোনাৰ
নেকি?
কুৱেশ্যনটো এনচাৰ কৰিলে নে নাই বাট
Yes. I understand. মই মঞ্জুল ভাৰ্গৱৰ লেকচাৰটো শুনি উঠি মোৰ কথাটো মনলৈকে আহিছে যে তেখেতে এই বস্তুটো আমাৰ ইন কনজাংচন উইথ দ্য ইণ্ডিয়ান নলেজ চিষ্টেম প্ৰেজেণ্ট গভৰ্ণমেণ্টৰ পলিচিৰ ওপৰত ক'লে যে আচলতে এইটো ইম্পৰ্টেণ্ট মোৰ প্ৰশ্নটো সেইটো মনলৈ আহিছিলে
তাৰমানে ছাৰ আৰু এটা কথা সংঘমিত্ৰা মই তোমালৈ আহি আছো হা
Sure,
ছাৰ
sorry.
আৰু এটা কথা মানে মই আজিকালি মোৰ ষ্টুডেণ্টবিলাকক সদায় কওঁ তাৰমানে প্ৰব্লেমটো হৈছে ল'ৰা ছোৱালীয়ে তাৰমানে পঢ়ি আছে কিন্তু একো কানেক্ট কৰিব নাজানে তাৰমানে এই যে
অ'কে
মানে আপোনাৰ ধৰক আমাৰ তাতে ফ'কাছ ইজ কেনেকে 100 পাব মানে কিন্তু
অ'কে
মানে আপুনি মেথছৰ যে বহুত বেলেগ বেলেগ কথা পঢ়িছে সেইবিলাক কেনেকে ইটো সিটোৰ লগত কানেক্টেড সেই বস্তুটোৰ একো ইণ্টাৰেষ্ট মানে একো পঢ়োৱাও নহয় প্লাছ মানে ল'ৰা ছোৱালী ইণ্টাৰেষ্ট নাই কাৰণ সময় নাই কাৰণ ইটছ অল এবাউট কেনেকে পৰীক্ষাটো লওঁ পাছ কৰোঁ বেটাৰ নম্বৰ পাওঁ এইটো হৈছে ৰাইট চ' তাৰ ফলত কি হৈছে ল'ৰা ছোৱালীবিলাকৰ কোনো ইণ্টাৰেষ্ট নাই কাৰণ মেথ ইজ অল এবাউট পাছিং দ্য টেষ্ট এণ্ড গেটিং এ বেটাৰ পাৰ্চেণ্টেজ ইট ইজ নট এবাউট the beauty of math. I start my classes with beauty of math, that this is going to be a hard class. So hey connection to ক্ষেত্ৰত তেখেতৰ কমেণ্টটোৰ ভ্যালু থাকিব because আপুনি যদি ব্যাকগ্ৰাউণ্ড বোৰ নাজানে খালি আজিকালিতো আৰু এআই সবে ইউজ কৰি আছে চ্যাট জিপিটিত কোৱেশ্চনটো মাৰি দিয়ে এনসাৰ আহি যায় so সেইটো ক্ষেত্ৰত তাৰমানে there is big value to knowing the root and the conceptual understanding of the theory. But it's also very important to teach the application. All theory পঢ়াই থাকিলে we are very behind. We are going to be nowhere close to where the rest of the world is.
Yes, thank you. মই বুজিছোঁ কথাটো
Yeah.
You can go to সংঘমিত্ৰা
মই সেইটোৱে একেটাই কথা সুধিব খুজিছিলো যে যিহেতু থিয়ৰী নপঢ়া এপ্লিকেশ্যনটো ৰিলেট নকৰে সেইকাৰণে ল'ৰা ছোৱালীবিলাকৰ ইণ্টাৰেষ্টটো কমি যায় নেকি
একদম কমি যায় তাৰমানে দুটা বস্তুৰ কাৰণে কমে এটা হৈছে মই যেটো অলৰেডি ক'লো যে দে আৰ ফ'কাছ ইয়াতো সেইটো মেথছৰ ক্লাছত আহি সবেই ভেৰি প্ৰাউডলি কয় আই এম ভেৰি বেড এট মেথ আই জাষ্ট ৱান্ট টু পাছ দিছ ক্লাছ ক'ৰবাত শুনিছেনে বেলেগ ছাবজেক্টত য'ত মানুহে প্ৰাউডলি কয় আই এম ভেৰি বেড এট ইট নকয় কাৰণ এইটো এটা মানে সেই আছে চ' সেই বস্তুটো তাৰমানে মোৰ লাগে ডেফিনেটলি one barrier. The other barrier is, I faced that a lot in my life, not learning what is the practical application of this mathematical concept. মই যে আজি কাউন্টিংৰ কথা কৈছো কাউন্টিং ক্লাছটো পঢ়াওতে আমি বহুত এই practical problem বোৰ দেখাও হিহঁতক যে password, right? Email, like why is Google updating their requirement for the password every few years, right? কাৰণ hackers are hacking into your email account and your bank account. So they are kind of making it harder to crack it, right? Because hackers are actually very smart mathematicians, I say, because they know how to figure out what are all the possible passwords someone can come up with. So hey bostutu jetia ল'ৰা ছোৱালীয়ে দেখেও I am on my phone all the time. So if I can connect my math to their phone, to their video game, to their day-to-day life, then they would think about it, oh, okay, that's why video game kheliye ase, no? So a lot of my projects are also about that connection. Ki, okay, linear algebra padha moi. So linear algebra is a very applied field, right? So all the applications are actually in the world. So our project bilak, so mane about this problem in economics, this problem in networking, this problem in graph theory, and then they kind of, so it's very important. Hetu nedekhale tar mane, unless someone like me who loves math for what math is, but hetu percentage birate horu, right? Zero, mane 1% no hoy tenuka manu pithibit. So you have to, you have to really connect it, make it relevant, because moi eta kotha biswas koru je studentক blame kori thaki lav nai. It isn't the fault of the student. I think it's the fault of the system. The parents, the teachers, the schools, everyone has to change and think about how do we make this student learn. I think what I feel is the curiosity is gone, right? ল'ৰা ছোৱালীবিলাকে আজিকালি শিকিবৰ কাৰণে নপঢ়ে, একো পঢ়িব লাগে কাৰণে পঢ়ে। সেই বস্তুটো মানে সলনি কৰিবলৈ হ'লে তুমি যিটো কৈছা এপ্লিকেশ্যন কানেক্ট কৰিবই লাগিব। আমি যদি মেথমেটিক্সক ভিডিঅ' গেমৰ লগত কানেক্ট নকৰোঁ আৰু মেথমেটিক্স নপঢ়িব।
No, Hiranada jitu kola networking, a graph theory applies in economics. We use graph theory in identifying the parts. Amar bostubo bahut dangor, right? Mane aerospace or ekhon like 3,000, 4,000 part thake. So use like graph theory exactly. So like it's such a wide application, like code economics, code building some aircraft. So
exactly,
that's also math.
Aeronautic engineering is actually one of the hardest major, and it is very mathematical. Karan physics and math at high level is the same thing. Karan Einstein koisile jodi more math to better hole then you'd have done much better work tar mane. Even Einstein said that if I knew calculus better, I would have done a lot better. So, okay. I know বহুত time. So thank you for staying. ভাল লাগিলে।
Thank you, thank you. I think আৰু যদি প্ৰশ্ন নাই, maybe we can conclude, নহয় জানো?
মই সৰুকে সুধিব খুজিছিলো যে ৰিচাৰ্ড ষ্টেনলিৰ এটা অপেন কুৱেশ্যন, এটা ইণ্টাৰেষ্টিং অপেন কুৱেশ্যন কোৱাচোন।
So maybe hey young tabler je kotha koi asilo, because one of the complication about stating a math problem is bahut background describe koribo lage. So I talked about how many young tableaus are there of a given shape, right? So their open problem that I'm working with a couple of my students is young tableau hoy, but now we are putting more restriction on what kind of young tableau you are looking at. It's called, we are bringing a statistics for each tableau, jitu ami major index boli kau. Ar hetia mane we are finding we need, so he said several years back that there is a combinatorial formula and a proof for calculating how many young tableaus are there with a given major index, And that problem seems easy and we can easily verify what he is suggesting, but coming up with a nice formula and a combinatorial proof, which I did not talk about, but it's a way of basically taking the problem and converting into a very familiar setup, and we call it a bijection. Apuni hoyto bijection or kotha janibo pare, a function that it's called a bijective proof. So Richard Stanley's problems are all, he has a paper on bijective proofs basically. A lot of these problems can be proven by a bijective proof, meaning problem to biology পৰা আহিছে বা economics পৰা আহিছে, আপুনি হেতু লয়, you convert it into a setup in mathematics which is familiar, and you count this setup. Aru, you create a function from your hard one to this one, and if it's a bijective one-to-one correspondence, তেতিয়া হলে ইয়াত যিবোৰ আমি easily answer, not easily, but mathematically answer koriba paru, you can now convert it into, transfer it into this word. So he said there is a bijective way to prove this connection, or the way we count standard Young tableaus with a given major index. Hey, প্ৰশ্নটো মানে আজি মোৰ এতিয়া 4 বছৰ হ'ল, we are not able to answer. I had 2 students went through, you know, but we are close. I think we're very close, and we are writing up. That's one of the things we are also doing this sabbatical, is to finish up that results, and and hopefully did open up door for a lot of students to come in and do some 1 semester work with me. This is all, lot of this is undergraduate research, which is amazing, because as an undergrad, if you can do this kind of research, they end up going to good graduate programs, and then so on. So that's one of the one that we are looking at. But he just have so many interesting problems that, and people just, the questions sound very simple when you hear the question. এইটো কৰিব লাগে, আৰু কেইটামান এক্সাম্পল কৰিবলৈও বিৰাট সহজ, কিন্তু যদি প্ৰশ্নটো মানে ডিটেইল ডাঙৰ কেছত দিব খোজে, then it becomes beautiful, I would say, rather than hard.
Thank you.
Hiranada, no, thank you again, Lipika. Apuni conclude koribo pare, I can share koribo parim next lecture to
Okay.
Sure, yeah, thank you দেই, বৰ ভাল লাগিল সবৰ লগত কথা পাতি, and hopefully people get inspired to look at new field of mathematics. And more email to দিয়া হৈছে, so if anybody has more questions, please feel free to reach out. ছাৰ, খুব ভাল লাগিলে আপোনাৰ হেৰি শুনি লগ, মানে কথা পাতি।
ভাল লাগিল, মই তোমাক দেখা পাই ভাল লাগিলে বহুত দিনৰ পৰা।
তাকে বাৰু,
কথাখিনি বৰ মন দি শুনিলো মই, বৰ ভাল লাগিলে।
বাৰু,
মেইন লেকচাৰটো
Hiranada, you can conclude.
Okay, Professor Lipika Deka, আজিৰ এই আলোচনাটো খুবেই ভাল লাগিল, ইমান এটা thought provoking, চিন্তা উদ্ৰেককাৰী শিৰোনামাৰে ইমান সুন্দৰকে মেথমেটিক্সৰ, গণিত শাস্ত্ৰৰ এটা ভাগ আমাৰ আগত, আমাৰ যিসকল ইয়াত অংশগ্ৰহণকাৰী আছে বা যিসকলে ভৱিষ্যতে এই আলোচনাটো শুনিব, তেওঁলোকৰ কাৰণে আগবঢ়োৱাৰ কাৰণে 15 মিনিট শিক্ষাৰ তৰফৰ পৰা তোমাক অশেষ ধন্যবাদ জনাইছো আমাক সময় দিয়াৰ কাৰণে। আৰু এই অনুষ্ঠানটোত যিসকলে আমাৰ জুম বা ফেচবুক বা ইউটিউব চেনেলত উপস্থিত থাকি আলোচনাটো শুনিলে, তেওঁলোককো আমাৰ তৰফৰ পৰা কৃতজ্ঞতা জ্ঞাপন কৰিছো। আৰু পুনৰবাৰ আমাৰ পৰৱৰ্তী অনুষ্ঠানটোৰ ঘোষণা দিব খুজিছো। আমাৰ পৰৱৰ্তী অনুষ্ঠানটো হ'ব ছেপ্টেম্বৰৰ 21 তাৰিখে ভাৰতীয় সময়মতে 7:30 বজাত, আৰু এই আলোচনাটো আগবঢ়াব ইউনিভাৰ্চিটি অফ টেক্সাছ টাইলাৰৰ পোষ্ট ডক্টৰেল স্কলাৰ ডক্টৰ শেখৰ সুমন বৰাই, আৰু তেওঁৰ বিষয়টো হ'ব ফ্ৰম ট্ৰেনজিষ্টৰ্ছ টু মেমৰিষ্টৰ্ছ, দ্য ফ'ৰ্থ এলিমেণ্ট অফ মডাৰ্ণ ইলেক্ট্ৰনিক্স। আশা ৰাখিছোঁ ইয়াত উপস্থিত থকা ছাত্ৰ ছাত্ৰী, শিক্ষক আৰু অন্যান্যসকলে ছাত্ৰ ছাত্ৰীসকলক এই অনুষ্ঠানটোত যোগ দিবলৈ উৎসাহিত কৰিব, যাতে 15 মিনিট শিক্ষাৰ আমাৰ যিটো লক্ষ্য উদ্দেশ্য, যে আমাৰ অসমৰ শিক্ষাৰ্থীসকলৰ কাৰণে কিছুমান গুৰুত্বপূৰ্ণ বিষয় অতি সহজকৈ তেওঁলোকৰ মাজলৈ লৈ যোৱা, সেই আমাৰ প্ৰচেষ্টাটোত আমি আগবাঢ়ি যাব পাৰোঁ। ইয়াকে কৈ আটাইলৈকে পুনৰবাৰ ধন্যবাদ জনাইছো, আৰু আমাৰ আজিৰ অনুষ্ঠানটো ইমানতে সামৰিছো। ধন্যবাদ।
Actually, sorry, মানে এইটো এজন শিক্ষাৰ্থীৰ এটা প্ৰশ্ন আছে, ডিম্পল ডেকা। Sorry, Dimple, please, I mean, প্ৰশ্নটো maybe সুধিবলৈ we will let you do it. Dimple, you are unmuted, তুমি ক'ব পাৰা।
Yes, sir. Thank you, sir.
Go ahead, Dimple.
Please.
Yes, ma'am. I have a question. That, ma'am, what are the role of mathematics in data science and AI, ma'am?
Oh, a lot. So data science and AI uses a lot of statistics, as you know. And in statistics, the theoretical statistics, a lot of the methods and a lot of the tools that you are using are very mathematical. And so I like to think that if someone wants to really be on the side of behind the scene of creating AI tools, you need to have very strong mathematical background and statistical background, right? So that's where I feel like there's a big connection, and a lot of our students are actually getting jobs in that area as a mathematician, you know. So so yeah, definitely Dimple, যদি সেইটোত interest আছে and if you like it, um, think of applied math and statistical courses, you know, they're definitely going to help. Statistics is big part.
Okay. So thank you, Dimple, তোমাৰ প্ৰশ্নৰ কাৰণে, আৰু I think আমি
মই ডিম্পলৰ এটা সৰুকে মানে চিনাকি দিব খুজিছো যে ডিম্পল
Oh,
আমাৰ যিটো ইকনমিক্সৰ সামাৰ কেম্প, এই সামাৰ কেম্পত এজন পাৰ্টিচিপেণ্ট আছিলে। তেওঁ এতিয়া BSc পঢ়ি আছে মঙ্গলদৈ কলেজত। গতিকে ডিম্পল,
oh,
থেংক ইউ তুমি জইন কৰাৰ কাৰণে। আশা কৰিছো তুমি আগলৈকো জইন কৰি থাকিবা, আৰু মেমৰ লগত যদি তুমি কথা পাতিব খোজা, প্লিজ তোমাৰ ইমেইলটো তুমি পালাই চাগে, ইউ কেন ডিৰেক্টলি কানেক্ট।
yes, please. Aru, stay curious. I think question hudhatu is the first step towards doing something. So, ভাল লাগিছে এই কাৰণে প্ৰশ্ন সোধা কাৰণে. So, yeah. আৰু এটা আছে Dimple or আৰু এটা question আছে নেকি?
Oh, okay.
Sir, I want to ask you one.
কোৱা
তুমি muted হৈ আছা দেই.
ডিম্পল, কোৱা।
তোমাক আনমিউট কৰি দিছো ৰবা। কোৱা। হেল্ল', কোৱা।
Maybe connection to বেয়া হৈছে চাগে।
Is it okay? কোৱা।
Yes, মানে মই আমাৰ গুৱাহাটী IIT তৰফৰ পৰা ডাটা সায়েন্স এণ্ড IIT ডাটা সায়েন্স এণ্ড AI ৰ ওপৰত এটা ডিগ্ৰী মেম পাইছো। সো তাতে মেম মোৰ মেথছৰ কোনখিনি বস্তুৰ ওপৰত ফোকাস কৰিব লাগিব বেসিক্যালি মেম?
So, so IIT চাগে graph theory class থাকিব, right? So definitely. আৰু computational class, any down types of computational class. আৰু AI ত মানে mathematical modeling use কৰে সিহঁতে, right? To convert lot of the things into. So I think most applied IIT to থাকিব, math modeling or যদি class থাকে, differential equation or যদি class থাকে, combinatorics, enumerative combinatorics or class থাকে, graph theory class থাকে, এইবিলাক টপিকৰ ওপৰত কৰিলে তুমি definitely you will see connection.
Okay ma'am.
So look for applied computational courses in IIT.
ডিম্পল, তোমাৰ এই খবৰটো মানে শেহতীয়াকে মানে অলপতেহে পালো। কংগ্ৰেচুলেশ্যনছ দেই। মানে ডিম্পলে এই IIT গুৱাহাটীৰ AI এটা প্ৰগ্ৰেমত তেওঁ নামভৰ্তি কৰিব পাৰিছে, আৰু এইটো বোধহয় চৰকাৰৰ ফালৰ পৰা পুৰা সম্পূৰ্ণ বিনাব্যয় হ'ব নেকি, মানে তেওঁলোকে খৰচটো দিব বোধহয়।
Other thing হৈছে ডিম্পল, যদি AI
Very
field
good.
enter কৰিছা, মানে নিজেও বহুত ইনিচিয়েটিভ ল'বা, কাৰণ lot of the AI things are available online. আৰু মই যিটো ষ্টুডেণ্টৰ পৰা শুনো, তাৰমানে AI যিবোৰ টুল আছে, ChatGPT হওক, Gemini হওক, এইবিলাকৰ যদি এক্সেছ পাব পাৰা আৰু এক্সপ্ল'ৰ দেম ইয়ৰ চেল্ফ, মানে কাৰণ AIটো মানে তুমি নিজক কিমান ট্ৰেইন কৰিবা, তেতিয়া সেইটোৰ ওপৰতো বহুত ডিপেণ্ড কৰে। তাৰমানে এতিয়া ময়ে ধৰা নিজেই লাৰ্ণিং আ লট এবাউট ChatGPT কেনেকৈ ইউজ কৰি মোৰ কামত ইউজফুল কৰিব পাৰোঁ, ৰাইট? আৰু বহুত বহুত কৰিব পাৰে তাৰমানে। কিন্তু ল'ৰা ছোৱালীবিলাকে সাধাৰণতে ChatGPT খালি হোমৱৰ্কৰ আনচাৰ ল'বলৈহে ইউজ কৰি আছে। চ' সেইটো নকৰি তুমি মানে ইউ গ' মোৰ ডিপাৰ, অ'কে? সেইটো মোৰ ছাজেশ্যন হ'ব। Maths পঢ়া, but also be different, not just use the tools to get answers to things, but learn from it. And it can be a really good learning tool, তাৰমানে সেইটো কথা। So তুমি ইনফেক্ট
Yes.
ChatGPT কে সুধিব পাৰা তোমাৰ এই questionবোৰ and see what they come up with, and so on.
Yes ma'am.
And it's a right field to be in right now. এতিয়াতো মই Silicon Valley-তে থাকো, ইয়াতেতো সব মানুহ খালি AI লৈয়ে পাগল হৈ আছে। এতিয়া startup, চাকৰি, হেন তেন সব মানে everything is around AI. Education is also around AI now. So আমাৰ এতিয়া we have become a AI focused institution.
Yes. Yes.
So,
Okay. Thank you, ma'am.
thank you. আৰু মোক ইমেইল কৰিবলৈ হেজিটেট নকৰিবা। ইমেইলটো এভেইলেবল আছে চাগে, ৰাইট? So, ভাল
Thank you.
লাগিলে।
Thank you, ma'am. Thank you, sir.
তুমি লাগি মানে তুমি নেপালে বিচাৰি মোক লিখিবা মোৰটো তোমাৰ হোৱাটছএপত আছা নহয় তুমি লিখিবা
হয়, sir.
তাকে।
লাইভ ষ্ট্ৰীমটো
Thank
আমি
you.
বন্ধ কৰি দিওঁ তেতিয়াহ'লে। Thank you again, Dimple. Thank you so much.
Thank you.
Thank you, Lipika. Thank you.
আৰু ভাল লাগিল দেই। তাকে তোমালোকৰ এই